Welcome, everybody, to the Across the Sky podcast, brought to you by Lee Enterprises and powered by our team of meteorologists all across the country. November is in full swing. Things are cooling down, and we are going to be talking about snow for most of this episode here. So we have Sean Sublett over at the Richmond Times-Dispatch. We have Matt Hollander covering the Midwest and Kirsten Lang in Tulsa. Has anybody here seen snow yet as of November 10th?
Not in Chicago. No flakes of snow yet. I have now, since I cover the weather across the Midwest, there have been flakes of snow in other places, including Madison, Wisconsin. That's one of my places. And there's been some flakes of snow in Nebraska, but nothing in Chicago yet. But I know it's not far away because it is cold now. we said goodbye after some wonderful record-breaking temperatures in the 70s. Goodbye. And I don't think it's going to be in the 70s for a long time.
We're recording this right on November 10th, Thursday, November 10th. And on the 7-day forecast, we actually in Tulsa have the S word for Monday night. Now, I don't know if it's really going to happen. I don't know. The confidence is kind of low, but we'll see.
When does snow season begin in Tulsa?
Usually a bit later. Our snowiest month really is more February, so it's kind of delayed.
Gotcha.
Yeah, because we're going to get, I think a lot of the country is going to get a pretty big shot of cold, Arctic, almost polar air toward the end of next week. So that's, 18th, 19th-ish of November, depending on the precise nature of things. So no snow here, hard pass on that. We had the warmest first week of November on record here in Richmond. But anybody who's followed the weather knows that the pattern is about to switch hard once this tropical thing, Nicole, goes through and the cold air comes rushing back into the States, at least the East Coast, for a while to come.
Yeah, Sean, it didn't really feel like a reality the first week of November. We broke record highs. We broke record warm high temperatures. We broke monthly records. I was literally sweating outside in November. Who needs Florida when you have New Jersey? I mean, that was pretty much the deal over the past couple of days here. But like you said, the pattern is changing. Snow is coming here, and we're continuing our mostly winter-themed month so far in the month of November. Most of our episodes this month are about winter, and we're talking about snow. And, this guy, a very special guest, at least for me. He is, I like to call him my weather dad, and he is appears frequently, I should say, on our Something in the Air podcast that we do here locally. He is the operator of the Rutgers Global Snow Lab. He is the New Jersey State climatologist. He's also the CoCoRaHS coordinator. That is New Jersey's and the country's largest network of volunteer weather observers. He is Dr. Dave Robinson. It is a pleasure to have you on here.
It's great to be with you. You didn't mention I'm your weather father because you interned for me many a moon ago.
You're right. I did. Yes. Back in the day, back in 2013, we talked about dew point climatology in New Jersey. I'm a sucker for dew point, so I appreciate you letting me do that with a big help from our friend Dan Zarrow. Shout out to Dan Zarrow for helping us out there. But I think with that, did I get all of the hats that you wear correct? Am I missing anything?
No, you did fine. I'm at Rutgers University, so first and foremost, a professor. My research side is with snow, and my service side, being the state university, is as state climatologist.
Right. Yes. And Professor Rutgers University teaches a class about New Jersey as well. But I'll stop with the New Jersey talk for here. We're going to talk about snow across the country and beyond. So, we had Judah Cohen on a couple of weeks ago. We did a two-parter with him on the winter forecast. You were actually on his PhD committee at Columbia University. So it's just funny that how we're all tying this all together. Weather is really a small world here. But what is a global snow lab? What does that do, and who uses that?
Great question. And Judah uses our data as part of his forecasting technique or toolbox. This goes back to my graduate school days when I studied snow on the ground and how it affects the reflectivity of the surface and in tune weather patterns and such, whether there is snow there or whether there's not snow there. And then we look at it in a long-term sense. And I've been writing papers about the loss of spring snow cover for over 30 years, and even mentioned the climate change world word, I should say, in a paper I wrote in 1990. So our job in the snow lab is more snow cover, as opposed to you meteorologists who are studying snowstorms. I'm a climatologist. I like to get the snow there and then see how snow is impacted by the atmosphere around it and how snow itself can impact the atmosphere. So we keep a record of the distribution of snow over northern hemisphere continents. I've looked at snow over Arctic sea ice in the past and so on, but primarily we're interested in where snow cover sits at any particular time over northern hemisphere continents. And we keep a database, and you can just snowcover.org if you go look in there, and you can look back to the beginning of the satellite record in the late 60s, and every month we have data there on the expanse of snow cover across Eurasia and North America. And then now, if you go on, you can look today at what NOAA's and the National Ice Center plotted for the snow cover yesterday. And we do an anomaly chart. So you can't just say, well, okay, there's the snow. Is that unusual or not? We'll tell you where it should be and it isn't, or where it shouldn't be and it is, as well as where it normally would be found. So it's a tool. It's used for national assessments. It's been used for the Intergovernmental Panel on Climate Change reports, and it's used by the Weather Service in their forecasting.
Hey, Dave, it's Sean down in Richmond, and I appreciate so much the work that you do there, because snow data is tough. There's so many people who measure it wrong, measure it right, all that stuff. So the satellite observations have helped a whole lot. How good is the data before the satellite era, if there is any data at all, when we try to think about, the satellite era, let's call that the 60s and 70s. But before that, when we're trying to think about how snow cover looked at the early to mid part of the 20th century, how is the data on that? Is it even there and or reliable?
Yeah, that's a great question, Sean, because what satellites did was open the door for an even playing field over all the continents. A lot of people don't live up in polar areas, and they're not there with their rulers measuring the snow. But there are long-term records of snow gathered at surface sites and then interpolated, averaged over areas, as opposed to being seen from aloft. And that's where you get measures on the depth of snow. We're pretty much looking just at the distribution of snow, not saying how deep it is. So there have been maps through the Weather and Crop Bulletin in the U.S. that go back in the early part of the 20th century, but they miss some of the mountain areas. They don't go up to the polar areas. So the record was sparse and geographically incomplete until we got to the satellite era. So there are older records. And I've published a little bit on that with a former colleague in Canada. And we found, for instance, the spring snow cover was greater in the past, in the pre-satellite era, and it's just continued to decline in recent decades during the satellite era. But that's more early spring, because by the time we get to the late spring, as I said a minute ago, the snow cover is up at high enough latitudes. I mean, who wants to live in a place where there's snow on the ground from September until June, unless you're a skier up on a mountain? So the records are kind of sparse when you get to the higher latitudes.
Sure. Before I hand it over to Matt, is there a definitive date when we would say the satellite record begins? Would we say 1970? Would we say 1965? Is there a year that we can kind of use as a mark?
And I should say that we don't map the snow. It's done by the National Oceanic and Atmospheric Administration. We take their daily snow product, or it used to be a weekly snow product, and we put a climatologic spin to it, can make it more consistent over time, and we maintain the database and we look at the anomalies. So I don't want to take all the credit for the mapping. Late 66, but the satellites weren't of... Mm-hmm. as prevalent, the resolution of the imagery wasn't as high. So there's a couple of eras. The late 60s until the early 80s, we have enough to look broadly over continents. Not so much in the summer, where there was still it was misunderstood whether it was clouds or snow cover. Then in the 80s and 90s, we had better satellites and we began to get more precise snow mapping. And then since the late 90s, we've gone to a daily higher resolution product. So we kind of have multiple eras, and we've tried to stitch that together into a longer time series.
And you mentioned the trend that we're seeing in the spring of the decreasing snow cover. And so my question is kind of a two-part question for why are we seeing that decrease in the spring? Is it because of a lack of fewer snow events during the spring months? Or, and this brings me to the kind of the second part of my question, is because we're not starting with as much snow from the coldest part of winter, the heart of winter, December, January, February. So what can you say about what's happening at the start of winter and the fall months and in the core of winter, and how does that relate to the decrease that we're seeing in the spring months?
Yeah, that another great question, and one that there's still some uncertainty. We haven't noticed major changes in the core of winter, and we haven't necessarily seen changes in depth. When the snow wants to melt, it melts pretty quickly through what we call feedback processes. The snow is very highly reflective. It takes energy to melt the snow, and some of the sun's energy is reflected back into space. But once you start the melt process, you get the surface gets darker and it absorbs more solar radiation, which melts the snow faster, which makes it warmer, which melts the snow faster and makes it warmer. So you get that feedback, and that's what we're seeing in the spring. We're seeing the warmer conditions really kicking off that feedback process, and the snow is retreating faster than it did in the past. Now, interestingly enough, in the fall, over the last 10 to 15 years, we've seen an increase in October and November snowfall, or snow cover, I should say. And that one, there's been a little bit of research done on it with some Canadian colleagues in this case. And they found that we've got a combination of circulation changes that have made the interior of our higher latitude continents cooler and been able to get moisture to them from the south and perhaps off a more ice-free Arctic Ocean. So you've had the cold and the moisture in October and November, where at the high latitudes, it's cold enough to snow. So you're getting more snow on the early side than in the past. So it sounds a little counterintuitive. Isn't the world getting warmer? Yeah, it's getting warmer, but there's still places cold enough to snow, even in October and November. And if you get the moisture there, you're going to produce a snow cover.
Would you say that this is partly because large bodies of water are not icing over as quickly as they had in the past?
We think it's twofold. One is, there's more open water in the Arctic, so you have that moisture that can make it into the higher latitude land covered areas. And number two, maybe some circulation patterns that are allowing some moisture to be pumped up from southern latitudes. But there you have to be careful, because you could pump up warmth with it as well and not allow it to snow. So that's an area of active research. There's a lot of nuts yet to be cracked. We don't have all the answers. That's what makes it so interesting, and why we need to keep monitoring this and other variables. One thing I should add before go on, this variable, snow cover extent, is the longest consistent, nonstop satellite environmental variable that's been mapped. It's been mapped longer than any other weather variable consistently from satellites.
And Dave, I would think that maybe the expansion of lake effect snow season might have something to do with that too. The fact that these lakes aren't icing over to the extent and as quickly as they used to. And so then you get more lake effect snow in some cases than what we've seen in the past. Is that playing a role? Have you noticed a trend there and an increase in lake effect snow? I know we've seen quite a bit in another one of the places I covered, Northwest Indiana. There was quite a bit of it last year for sure.
Yeah, you've seen more of it at times, as long as you get that cold air down into the region, and it comes after a warm spell that's kept the lake open. Now, Ontario stays open, Erie doesn't. Sometimes Michigan doesn't. Most often there's some open water. There haven't been big trends in increased lake effect, but let's take it a broader scope. Let's go up to the Arctic Ocean. and find large areas of the Bering Sea, the Beaufort Sea, the Chukchi Sea, and beyond, the Kara Sea up north of Europe. Those are large bodies of water that have stayed ice-free. Maybe even Hudson Bay. There's just not a lot of good data around Hudson Bay. So, lake effect is fabulous and interesting in the Great Lakes, on even smaller lakes than that. But up in the polar regions, there's just open water well into the fall that just has never been seen there.
Lake effect, you're saying some interesting places. I always like the Finger Lake effect snow in New York when you get this angle of the wind just right coming out of the north. And you see a little bit of snow on those southern edges of the Finger Lakes. But talking about, maybe some more specific events, we have seen there's been a clear trend over time of precipitation occurring in more extreme events. Are we seeing that carrying over into snow as well? And I guess we can just limit it to the United States, although, feel free to expand beyond that.
Yeah, there's been a few studies. I was involved one. Boy, we need to update. It was over 10 years ago, where we were finding that there seemed to be more larger snow events up in the upper Midwest and the northern plains than we'd seen in the past, and particularly in the middle of winter, because you were able to get more moisture up there. And that's whereas further south, maybe a couple of former snowstorms were becoming rainstorms, because the one thing I always stress when I talk about snow is that magic freezing point. It makes all the difference. And if you are a couple of degrees below it or a couple of degrees above it, you've got a rain or a snow event. And the other thing is, we know the warmer it gets, the more potential moisture the atmosphere can hold. So think about a 15-degree snowstorm and a 30-degree snowstorm. The 30-degree storm may have more moisture to work with and pump out more snow than a storm at 15 degrees. And with a climate change world, there's still a lot of cold areas where it's going to keep snowing. And we might, for at least a period of time until it warms even further, see more snow in some areas that are moisture limited for snow right now, particularly in the middle of the winter, because it's just been so darn cold in those areas. So it makes for a challenge for the forecast community and also for anything to do with studying climate change. But of course, that makes it all the more interesting.
And it's easy for you to say, you deal with the climate. We deal with the hard day-to-day stuff and getting all the feedback.
Yeah, but you get the instant gratification, not just condemnation.
That is also true.
If we make climate predictions, we hope we make them far enough in advance that no one will remember they're wrong by the time we get to that point. And by the way, let me add very quickly, I don't venture to guess in terms of long-term predictions of snow. You can do a little bit, La Nina, El Nino signals, but it's bad enough to look months ahead for temperature and then precipitation. And then how about try to put the two together and get a snowfall prediction? No, not going to touch that.
Yeah, it is hard to forecast. I want to everybody make it clear. Winter weather, I kind of dread it the most. It is the most challenging forecast to make, whether it's just figuring out just what kind of precipitation is it going to be, sleet or freezing rain or snow or just all rain, and then when is the transition going to happen between all those types, and then figuring out the amounts, because unlike rain that a lot of it just soaks in the ground, you don't see it, the snow, it just piles up on the ground, and so then it's very noticeable, and those little differences in the amounts of the amount of moisture available in the atmosphere really matters when it comes to snow, because it can make a big difference on what actually falls. And I think one of the things that is confusing when it comes to talking about snow and climate change is people are like, well, then why is it, if the climate is warming, why is there still snow? Why are we getting these big snow events, 10, 12, 14 inches of snow? Weren't we supposed to not see that anymore with climate change? When, of course, again, we come back to it's a very gradual process. But what makes it so hard for snow is the atmosphere, like we say, for these big, heavy rain events, we're still seeing an increase in heavy snow events as well because of all the moisture that's in the atmosphere, this increase in moisture content when it gets cold enough. And I think sometimes the challenge now, especially in places farther to the south, is oftentimes you have the moisture but not the cold. But when the cold is there, now we have all of this moisture. We're sometimes still getting these really big snow events, and then maybe it'll go weeks and weeks and it won't snow again, but you'll have a really big snowstorm that'll cripple a place for a week or several days. And people are like, oh, it was a terrible winter. But then overall, it was like, well, besides that one snowstorm, it actually wasn't that bad. But that's interesting. We're still getting some really big snow events, even though maybe the number of events is going down, but there's still some big snow events that you have to watch out for.
Actually, I had a high school student do a little internship with me last year, and he found in New Jersey, while we haven't seen snow totals change, there's a lot of interannual variability, mind you, but we haven't seen a signal of any change in any direction. But he did find that there was more of a prevalence of the snow falling in larger events now, rather than those smaller events. And I like to just say, you can pop a big snowstorm and you're going to be able to do so for years to come. It's not as if we're warming that rapidly.
Yeah, I think that's a really good point, Dave. People just think snow, it's cold, not also understanding that there is a point that I think we all remember as undergrads, the phrase, it's too cold to snow, meaning that it's cold. It's so cold that the air is too dry to support big time snow. And I think that's what's counterintuitive to a lot of the general public. They see snow, they think it's cold, where as you get closer to the freezing point from the cold side, you will tend to actually have more snow until you cross that threshold, as you mentioned before.
Yeah, that's why I say, you'll be skiing in Alaska in the future or at higher elevations here in the lower 48.
Let's talk about actually measuring the snow here, because, oh boy, I mean, every snowstorm, people, with good intentions, for 99% of the people send in totals, but the ruler might not be, in the right place, or they might be measuring on a driveway that has a black surface, or, if they're measuring on a snowboard, which we'll get into in a second, they might be clearing the snowboard too often, not often enough. Every once in a while, you get people who are trying to intentionally inflate totals. So people like the four of us here will post them out. My rule of thumb is I always like to see, I won't include a snow total unless someone takes a picture with a ruler in the snow. But anyway, I digress. Tell us, what is the official right way to measure snow?
Right. When it comes to CoCoRaHS training, 3/4 of the training is how to measure snow. So it's real easy if you're a CoCoRaHS coordinator in Florida.
That is true.
But there is the NOAA, National Oceanic Atmospheric Administration, National Weather Service, has snow measurement guidelines. You can Google it and download a free PDF. The reason I know that, I was on the committee that's twice updated the standards for this, along with Nolan Doskin, the founder of the CoCoRaHS program out at Colorado State and the former Colorado State climatologist. We're both snow guys, and we were invited onto this federal committee. And I don't know, it's 50, 60 pages or more long. And it involves all the aspects of snow measurement. But you nailed it, Joe. Right now, unless you're asked to do otherwise by your National Weather Service office, and it's often done at airports with 6-hour measurements, the official way of measuring snow is to get a snowboard, white, put it out over an open area. Doesn't always work because it can get windy, and then you may have to go make a suite of measurements or find an area that's the least windy. You're to attempt to measure the greatest depth on that board over a 24-hour period. Now, you can't stay up all night, but you can use a little art there with some science when you've done it a while. So you're not supposed to just take it at your normal 7 a.m. observing time, because it could have stopped 12 hours earlier and the snow compresses, or it could turn over to rain. And, you report no snow for the last 24 hours, but they were plowing it yesterday afternoon before it washed away. Or in the opposite sense, you just love it. It's snowing to beat the band. You go out there every hour, you measure it, clear your board, measure it, clear your board. You don't give it any time to settle. So you get an inflated total. So the whole idea of these measurements, and this is really the take home, is try to even the playing field when it comes to measuring snow. So you don't get that snow exaggeritis, but you also don't get the absence of snow. And so you wouldn't believe the debates we had on this committee of 8 or 9 of us, in how to settle on a happy medium where you don't measure too often, but you measure often enough, and then try to get that word out to the Weather Service offices who train people to do observations. So the idea there is not to overmeasure, but to keep an eye on things so that you don't end up under measuring.
And you know what, just to cap off with this, sometimes too, and we can talk about this in a minute, but, if you have a smaller backyard, a lot of times you might have a tree covering most of your yard. I mean, at my parents' house, when I growing up, that was our case. You don't have the biggest yards, but there are ways to get about and measure snow accurately and have some fun too while we do it. So we're going to take a break right here, but we'll come back. We have plenty more with Dr. Dave Robinson. You're listening to the Across the Sky podcast.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
NASA's Artemis 1 mission, which will test all the technologies and systems that are needed to return astronauts to the moon, is set for another launch attempt early Wednesday morning, with a 2-hour launch window that opens just after 1 a.m. But another lunar mission reached the moon over the weekend that you might not have heard about. The Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, more easily referred to as CAPSTONE, is a microwave oven-sized CubeSat that weighs about 55 pounds. It fired its thrusters entering a very unique lunar orbit on Sunday evening. That orbit, it's a near rectilinear halo orbit, or NRHO. And CAPSTONE's the first spacecraft, albeit a tiny one, to fly an NRHO. It's also the first CubeSat operating at the moon. An NHRO is a significantly elongated orbit, and that's remarkably stable. But better yet, it offers better fuel efficiency over other options for orbiting the moon. When we go back to the moon, it's going to be a lot less like Apollo, where we spend a couple of hours or a few days on the lunar surface before returning home. It's going to be a lot more like the modern era, where astronauts spend months doing science on the International Space Station. NASA, along with the other nations that make up the Artemis Accords, plan a small, also human-tended space station orbiting the moon called Gateway. This is where astronauts will take day trips to do that science on the lunar surface. And this solves many of the complexities that living on the surface of the moon brings with working there. You see, Gateway will also fly an NHRO, and CAPSTONE is providing valuable planning data. Elsewhere in the sky, the Leonid meteor shower peaks before dawn the morning of Thursday, November 17th. Now, this isn't a particularly active shower, but it's been known to produce outbursts in the past, with 100 or more meteors per hour visible. It hasn't happened since 2001, and it's really not expected to happen this year. But data does indicate that there could be a few more meteors than usual visible on the night after the traditional peak. So if you see a bright streak across the sky later this week, it could be a Leonid. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
Thanks, Tony, for that. And we are back with the Across the Sky podcast, joined by Dr. Dave Robinson. He runs the Rutgers Global Snow Lab. He's a professor at Rutgers University, the New Jersey State climatologist, the New Jersey coordinator for CoCoRaHS, and my weather dad as well. So we are talking all about snow here and everything that comes along with measuring it and recording it. We'll toss it over to Kirsten. She had a question about CoCoRaHS.
Yeah, well, I was going to ask too, Dave, for people that are listening in, that are maybe not as familiar with CoCoRaHS, where it originated, just the ins and outs of it. Could you expand on that just a little bit too? Because you may have some listeners that haven't heard and could possibly decide they want to volunteer.
Absolutely. Sure, I'd be happy to. Anyone who's caught the interest and has hung on to listen this far into it, it's definitely a candidate to be a CoCoRaHS citizen science volunteer. This is a program of citizen science volunteers. It's spun off of a program of a deadly flash flood in Fort Collins, Colorado, back in 1997. And Nolan Doskin, the state climatologist out there, said we didn't have enough readings of how much rain fell so we could coordinate. Radar wasn't so great up against the Front Range and such. So we got a bunch of high school students the next summer to start developing some software, and they gathered some volunteers. It went out to all of Colorado, then to the high plains in the early part of this century. And people began measuring precipitation with a standard rain gauge every morning, generally. And they'd enter the data, they'd call it in, or they'd get on computers mostly and enter it into a database. And then it just started growing, and it went across the US. It's now in Canada, it's in the Bahamas, and it's got, oftentimes 15,000 reports plus a day. And it's an invaluable source of information on precipitation, rain, snow, and hail. No temperature measurements are made. People make anecdotal measurements of drought conditions, to how dry it may be, because there's room for comments to be made. You can go on your Android or your Apple, your phone. You can go on the computer and enter this. There's all sorts of training materials, cartoons, and material you can read to show you how to make these measurements, where to put your rain gauge, and how to enter the data. And you can go on, and it's publicly available for people who don't make measurements. You can go on CoCoRahs, CoCoRahs.org, and you can look at it to your heart's content. You don't have to be one making an observer. So it's great for schools to look at, for the students to look at. You can see if what your neighbor got a couple miles away for precipitation, or what a friend got on the other side of the continent, or out there in Oklahoma. So, Oklahoma has a wonderful mesonet with 120 some odd stations gathering data every 5 minutes. In Jersey, we have 66 stations in our mesonet, but we'll get we've had 285 observations last month in one storm, and it fills in all the gaps. And it's so useful for the Weather Service, for flood forecasting, for monitoring drought and other agricultural concerns, for emergency management purposes. It's just got a multitude of uses. So I can't speak strongly enough about it. It is the premier citizen science program in the country. And there are other wonderful ones that look at ecologic things, but this is a daily type, and you don't have to do it daily. About a third of our observers miss less than a couple of days a year. Some only observe when it rains. And we like to hear the zero observations as well when we're monitoring drought. But I really encourage you to give it a shot. Give it a shot.
Yeah, CoCoRahs is great. And if you do have an interest in weather, you find yourself, you're the type of person that says, kind of wish I could go back to school and be a meteorologist. CoCoRahs is a good way to get started, to kind of get if you've got that interest in weather. It's a great organization to get involved with, because those observations really do make a difference. But let's say it's someone who doesn't have quite as big an interest in weather, but especially I see this in the South, where it doesn't snow as frequently. People still get real excited when it snows, but it happens so infrequently in some places. People are still a little unsure about how to make those snow measurements. And one of the questions I see often is, where is the best surface to measure snow? So obviously you mentioned a snowboard. Well, in the South, a lot of people don't have those snowboards. So if they're just at their house, they're stuck at their house and it's snowing, where should they go if they want to submit a snow report about what they're seeing at their location? Where would be the best place for someone to do that in their backyard or front yard?
Yeah, it's a real good point. They wouldn't necessarily have the snowboard out there. You want to go to a place with as little wind as possible, so the snow won't blow away or blow into a drift that you're measuring and exaggerating it. But you'll have to worry about the surface it's on. If it's on a driveway, it can retain too much warmth and it will melt from the bottom up. So you don't want that. If you do it on grass and you stick your ruler right in the grass, you're going to be measuring a lot of air at the grass snow interface. So you have to take that into account. So in some cases, it could be a picnic table. It's not ideal, but for areas where it doesn't snow all that often, as long as that picnic table hasn't had the snow blow off of it, that might be the best place to do it because it gets cooled from below and it allows the snow to accumulate. You want to stay away from a house. You want to you don't want it under the trees because the trees may be intercepting a lot of it. It's tricky. It's really tricky. As I said earlier, it's science and a little bit of art, a little skill there in order to get a representative snow measurement. And if the snow's really blow around, you take a transect perhaps through your yard. But then the tricky part is you're trampling down the snow. And then if you want to make a measurement tomorrow of how much snow remains on the ground, or the next day, how much snow remains on the ground, you don't want to be trampling all the surface where you're making the measurements. And that's what interests me. I love a snowstorm as much as the next person, but my interests are once the snow is on the ground, how long it stays there, at what depth, what's the water content of the snow, and so on.
Let me throw one out there and get your opinion on it. What about the hood of a car? Now, I know the big one would be if it's a car that has just been driven, then it's going to be a warm hood and it's going to be melting some of that snow. But if it's been sitting in the driveway, and it wasn't being used, and if the car was cold when the snow started, could that be a good service if you don't want to use the driveway? If the car has not been recently used and it was there parked at the start of the event and then is still there and was not driven at all at the end of the event, before you brush that snow off your car, could you measure the snow on the hood or on the trunk of the car?
Yeah, you could measure it on there. I'm tall enough, I'd measure it on the roof. Yeah, you could, again, worry about the wind blowing it and so on and so forth. But if it's an infrequent type of thing, yeah. You don't want a refrigerated surface because that can exaggerate things. We were chatting off during break about what happens if it snows all day and the ground never gets white. What's your snow measurement? Well, if you had a cold, you took something cold out of your freezer, the snow would stick on that. There's no snow around. That's considered a trace of snow. If it never whitens the ground to a measurable 1/10 of an inch or greater, even if it snows all day, it's considered a trace of snow. Some people love to say, yeah, but we had 3/10 of an inch of liquid in my rain gauge. And it's a 10-to-1 ratio, isn't it? Liquid to snow. So that's 3 inches of snow. We had 3 inches of snow today. No, you didn't. You had a trace. Again, there's a lot to get into. And I'm not trying to dissuade people from measuring snow. I love it. But you need to do it right. I sound like an old professor, which I am. But, if you're going to do it right.
It's true, and it's important. And avoid the trees. That's a big one. You want to do it in an open area. I do see that. You will definitely underdo those snow amounts if you're making a measurement under the trees. So do it in an open area. That is another big one that I've seen.
And that website, again, is cocorahs.org, COCORAHS.org, if you're interested. I want to take a step back and talk a little bit about yourself and mainly what got you interested in snow. For a lot of meteorologists, it's one event that gets people hooked into weather. You're a climatologist, not working specifically in meteorology, but was there something there that really got you into snow, or you just kind of fell into it?
I fell into the snow. That was probably
good answer.
I grew up in North Jersey, just north of New York City, outside the city, so not in the snowiest part of the state, but in my youth. We had a couple of real snowy winters, and I'm a child of the 60s, which had the most snow of the entire 20th century. I have contemporaries say there was a lot more snow when I was growing up. And my wise guy answer is, well, you were shorter then, so it looked like more snow. But in reality, it was the snowiest decade of the 20th century. So you're right, it was snowier in the 60s than the 50s or the 70s, although we had some good snows later in the 70s. I've loved, like all you guys, I'm sure, and I just loved it since I was a kid. My first week of kindergarten, there was a hurricane, but somehow I didn't get into studying hurricanes. But it was just something about snow. how it changes the landscape. I'm not a downhill skier, I'm a cross-country skier, but I used to love to go out and shovel it. My parents didn't have to persuade me to go out and shovel the snow. And I'd shovel it into the shade so the pile of snow would last longer. It's just something, all of us get this bug. And for me, it was snow. And what a treat to be able to study this from my graduate school days on to present and get paid, get paid to do it. It's been great, but it's just one of those things. I can't pick out one snowstorm in particular, but some snowy winters in my youth.
You remind me of myself, because I used to shovel the snow like onto the middle of the street, because I thought, well, if the plow can't come through, maybe school would be canceled for one more day. Yeah, I thought that my street, because my street was actually on a middle school street, so there was a little merit to that. But I don't think my shoveling ever really made a difference on whether or not school would be open. But it was funny. So you went to Columbia. Now, when you were in Columbia, what did you get a PhD in, and what was the research like there?
Yeah, I mean, I started as an undergrad in geology because I just hadn't thought of meteorology for a career. I was thinking environmental law. But I got tired of hearing about lawyers in the 70s. We won't get into that. But I got turned on to geoscience. So essentially, when I went off to grad school at Columbia University and the Lamont Doherty Earth Observatory, I would consider doing geoscience. I was doing some paleoclimate work, but I was doing some taking marine geology courses and so on and so forth, and taking some atmospheric science courses at the Goddard Institute of Space Studies, which is a NASA lab adjacent to the campus in Manhattan, the Columbia campus. So I had, what a treat to study climatology with Jim Hansen, some people listening may know of, and paleoclimatology with Wally Broker, who coined the term climate change. Just amazing mentors. And came out of it with a degree kind of sitting on a lot of fences doing geoscience, or before it was even called the geosciences in some respects. So very fortunate.
When you got out of Columbia here, what was your next step? I mean, you've been New Jersey State climatologist, as we like to say, as long as I've been alive. So that's at least 30 years. So what happened before those 30 years started?
Yeah, when I finished my degree at Columbia, where I had been even as an undergraduate, I summer interned because I lived near there, although I went to college out in Pennsylvania. I stayed on as a research scientist, studying snow, studying the snow albedo, the reflectivity of snow, and realized it's really tough to bring in research grants to pay your salary all the time. And said I wanted to get a teaching position. I'm from a family of teachers. And I was fortunate enough to get hired at Rutgers in the geography department as a physical geography professor, even though I don't have a degree in geography, but it's close enough. It's Earth system science even. I said geoscience, but really it's Earth system science and kind of the nexus of humans and their environment and the influence they have on one another. But I had been at Columbia 4 years. I spent 1 year in Asheville, North Carolina at the National Climate Data Center, which is now National Centers for Environmental Information. It's kind of Mecca for climatologists. And came up to Rutgers, 3 years at Rutgers as an assistant professor. One of the deans said, our state climatologist is retiring. Actually, the state climatologist told me that. And would you like to be the next state climatologist? It's an appointment through Rutgers University, the land-grant university of the state, via decree of a governor in the 1970s. So, I mean, I was a kid in a candy shop. And I accepted the position, and now 31 years later, I'm the longest serving state climatologist the country has had, and certainly the longest one now, still active. And it just doesn't seem possible. It's been a wonderful gig.
It certainly has, and we are truly in the presence of a legend. right now, talking about the longest served state climatologist. Now you're saying ever of all time? Is that what we're referring to? Ever
Yeah, it
of
was a
all time?
federal position in the 50s, 60s, and the early 70s, and then it was abolished. And at that point, land grants and some State Department of Environmental Protection or whatever they're called took up and started state climate offices. And up until about last year, the former state climatologist of Iowa had been at it longer, but he retired about 4 years ago, and he started about 2 or 3 years before me. So, you know,
catching up.
I've passed him as the longest serving state climatologist, a record to be broken.
I don't know. We'll see. I mean, 31 years is a long time, and you're still going too.
No, I'm not doing
like
it for 60 years. I'll tell you that.
So maybe if someone's listening who's 12 years old, you might be, if you start at 22, 60 years, you might be state climatologist for that long.
Well, that's exactly right. I was 22 when it started.
Absolutely. That's I wouldn't have thought anything else.
Yeah.
All right. So great conversation. I really appreciate you coming on here. I know we all enjoyed having you on and talking all things snow. Where can we find more information about the Snow Lab and about the work that you're doing?
Yeah, well, snowcover.org will get you to our Global Snow Lab site, and you can look at how much snow is sitting on the ground across the Northern Hemisphere today and where it should and shouldn't be. That's there. And if you want to look at the State Climate Office, we're njclimate.org, and you can see what we've got from the State Climate Office side, and it will link you to our weather network, the NJ WeatherNet. So a lot of balls in the air. It's just wonderful to be able to talk weather and climate with you folks. I've really enjoyed it.
Absolutely. We enjoyed it as well. And I hope everyone listening did too. We'll have more for you coming up a little bit in the Across the Sky podcast. Let's take a brief break and thank Dr. Dave Robinson one more time. We'll be back with you in a minute. All right, everybody. So, Dave Robinson, somebody I know very well. What did you guys think of him?
Dave is just great. I mean, I like to think of him as Dr. Snow. If there was a question about snow, especially from the climatological standpoint, I think most of us are really good with letting people know this is the best way to measure snow. But when we think about the larger overarching questions, somebody who knows snow in and out, the history of snow, where it is, where it's not, teleconnections, all that kind of stuff, Dave's the go-to guy. He really is.
Yeah, I thought it was just a very interesting conversation. Now that we're in November, I mean, that seems to be definitely the buzz right now. Boy, thanks to everyone who listened to our Winter Outlook podcast. That is our most listened to podcast yet, our most listened to episode. So thanks for everyone for tuning into that one. So we clearly know that y'all have asked, and we gave you more snow information and more winter information. There's definitely some interest. So now I just hope that we, again, I think part of it is there's some people that are tuning in hoping that there's not going to be any snow, because I know some people hate it, but there are definitely people that love it. Lots of strong opinions. I'm right in between when I don't have really strong feelings for snow. I want a couple of snow events throughout the course of the winter, not too many, not too few. And of course you can make an argument what's too many and what's too few, but I just don't want there to be snow all the time. But I also want there to, be some occasional snows. And yes, I really like it when it snows on Christmas Day. So rooting for a white Christmas this year.
Which we learned though when we were in that podcast, it's less and less likely these days that you get a Christmas Day snow.
Yeah, that's been a trend, especially in December lately. Lots of folks getting disappointed. And you look at the climate normals. They released the new climate normals, and there is a % chance for every location in the country of a white Christmas. And especially in the South, the chance of a white Christmas going down as the climate warms. But that's what's interesting about snow is we're still getting big snow events because of the moisture content, because of climate change going up. You can still get big snows, but you just need the cold air to be in place. And when it is, watch out, because it can still snow a lot.
My mom always likes it to snow on Christmas, so then nobody comes over to our house, for Christmas Day. So she can just hang out. So it hasn't happened since she started hosting Christmas. But we got darn close back in 2010. It snowed the day after Christmas. The Boxing Day blizzard my favorite snowstorm of all time, but we just missed Christmas Day by one. We had 28 inches of snow in New Jersey, where I was back then, back in Union, New Jersey. So anyway, this was a great episode. A lot of fun with Dave Robinson. Really good to talk to. A great speaker as well, which is always great when you're doing this kind of long form audio like this. So we'll certainly take it. Looking ahead for you guys, next week we actually go from snow to hurricanes. We're going to be talking with Nick Underwood. He is a hurricane hunter and engineer, very popular in the Twitter sphere as well, if you're on Twitter. And then at the end of the month, we're doing our top 10 weather songs of all time. And that does include some winter weather as well. So like I said at the top of the show, November is a mostly winter weather month here on the Across the Sky podcast. So until next week, everybody, take care. Thank you all for listening, and we'll see you soon.